Okay, in this section, we are going to build on the patterns that we developed for exponential expressions, including negative exponents. So let's take a quick review. 9 squared would be 81. 9 to the first power is 9. 9 to the 0 is 1. And we keep dividing by 9 to get the next values. 9 to the negative 1 is 1/9. 9 to the negative 2 is 1/81st. Remember, dividing by 9 is the same thing as multiplying by 1/9. Okay, now I purposely left a blank in between these with the idea that we would squeeze in one extra number in between. So I want you to think about going in this direction. We're multiplying by 9 rather than dividing by 9. And if I wanted to take steps in between, I could multiply by, instead of 9, by 3. So if I multiply by 3, 1/81st times 3 is 1/27th, times 3 is 1/9, times 3 is 1/3, times 3 is 1, times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81. So let's figure out what must be in between. Let's start right here, in between 9 to the 0 and 9 to the 1. It's like a half step, so it's going to be 9 to the 1/2 in between. Now, you might be looking at that thinking, what does 9 to the 1/2 mean? Well, it appears to mean the square root of 9, which is equal to 3. All right, now let's take a look at some other half steps. So we have 9 to the 0 counting up, 9 to the positive 1/2, 9 to the 2/2, which is 1, and then we'd have 9 to the 3/2 is 27, and then 9 to the 4/2 is 9 to the 2. So let's talk about the 9 to the 3/2. 9 to the 3/2 appears to have something to do with the square root. It is the square root of 9, which is 3, but then raised to the third power. So it looks like the denominator 2 represents the root, and the numerator 3 in the exponent represents the power. So we take the second root, and then we raise it to the third power. Let's keep going in the pattern. It looks like we have in between 9 to the 0 and 9 to the negative 1, it looks like we should have a 9 to the negative 1/2. And that's just going to be 9 to the negative 1/2 is equal to the square root of 9, but raised to the negative 1, which would be 3 to the negative 1, or 1/3. And then 9 to the negative 2/2, 9 to the negative 3/2, and then 9 to the negative 4/2. So 9 to the negative 3/2 is 1/27th. Now let's do something similar, but with powers of 8. So with powers of 8, we can say 8 squared is 64. 8 to the 1 is 8. 8 to the 0 is 1. 8 to the negative 1 is 1/8. This time, I want to put 2 steps in between. So the pattern is multiply by 8, but I can put 2 steps in between each step by multiplying by 2. So 1/8 times 2 is 1/4. 1/4 times 2 is 1/2. Times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And then we get up to 64 by multiplying by 2 again. So let's see what we've got here. It looks like we put 2 steps in between. So between 8 to the 0 and 8 to the 1, we should have 8 to the 1/3 and 8 to the 2/3. And we can go in the opposite direction too. 8 to the 0, 8 to the negative 1/3, 8 to the negative 2/3, and then 8 to the negative 3/3 would be 8 to the negative 1. I don't want to belabor this too much, but it's the same exact pattern. The denominator here is the root, though, so 8 to the 2/3 would be the third root of 8 raised to the second power. So that's going to be 2 raised to the second power is 4. All right, same idea. So in general, when we have fractional exponents, if you have x raised to the 1 over b power, that's going to be the bth root of x. If it's 1/2 power, then that's the square root of x, and we don't generally write the index for the square root. X to the a over b is the bth root of x raised to the power of a, or it's the bth root of x raised to the power of a inside the radical. Both of those are equivalent. Depending upon what we're doing, one form may be easier to use than the other. And whenever we have a negative fractional exponent, use the negative for the numerator of the fraction, not for the denominator. It will make it much easier to deal with. All right, so 64 to the 1/3 is the cube root of 64. We're changing it to radical form. The cube root of 64 is 4. 100 to the 1/2 power is the second root, or the square root of 100, which is 10. 8 to the 4/3 is the third root of 8, then raised to the 4th power. So that's going to equal 2 raised to the 4th power, which is 2 times 2 times 2 times 2, which is going to give us 16. All right, 5 raised to the 2/3 is the cube root of 5 squared, or the cube root of 5 squared. Either way, for purposes of this one, we're not going to be able to take the cube root of 5, so we're not going to be able to simplify that as a whole number. So it may be easier for us to just leave this expression in the form the cube root of 5 squared, which would be the cube root of 25. Simplified radical form, that's as simple as that one gets. And then 9 to the negative 1/2 is the second root of 9 raised to the negative 1. So that's going to be 3 to the negative 1 is 1/3. 125 to the negative 2/3 is the third root of 125 raised to the negative 1. So that'll be 5 raised to the negative 1 is 1/5. 4 raised to the negative 3/2 is the second root, or the square root of 4 raised to the negative 3 power. So that's going to be 2 raised to the negative 3 is 1/8. 3 raised to the negative 1/2 is the square root of 3, or the second root of 3 raised to the negative 1. That's going to be 1 over the square root of 3. Can't leave that as a radical in the denominator, so we're going to rationalize that, and it's going to become the square root of 3 over 3. All right, try A below on your own. Pause the video. There's the answer to A. Now try B. Here's the work and the answer for B. Now try C. Here's the result for C. If you had written the fifth root of 2 raised to the 4th power and put the 4th power on the outside, then you just really have to write this as the fifth root of 2 times the fifth root of 2 times the fifth root of 2 times the fifth root of 2, and then simplify that by multiplying together the radicals. You can do it both ways. All right, in example 2, we are going to have multiple operations. So we have 4 times 25 to the negative 3/2. We have to do the exponent first. So that would be the square root of 25 raised to the negative 3rd power. Still have an exponent to do, so that's going to be 4 times 5 to the negative 3rd, or 4 times 1/125th. Now we can do the multiplication. That's 4 125ths. In B, we have 5 times 32 to the negative 3/5. That would be 5 times the fifth root of 32 raised to the negative 3 power. Well, you might remember that 2 times 2 times 2 times 2 times 2 is 32. In other words, 2 to the 5th is 32. So the fifth root of 32 is just 2 raised to the negative 3rd power. So that's going to be 5 times 1/8 is 5 to the 8th. Always remember to do the exponent first and then do any multiplication. And then in these next couple of examples, that's going to be followed by subtraction. All right, so in C, we have the exponent to do first. I'm going to bring down everything else. So this would be the square root of 25 raised to the negative 1. So that's 1 minus 2 times 5 to the negative 1, or 1 minus 2 times 1/5. Now we have the multiplication, and then finally the subtraction. And 1 is 5/5, so 5/5 minus 2/5 is 3/5. Last one, 2 plus 3 times 125 to the 2/3. So that's going to be the third root of 125 raised to the second power. So we need to continue doing the exponent here. That's going to be 5 to the second power, or 2 plus 3 times 25. Multiplication is next, so 3 times 25 is 75, plus 2 is 77. All right, try A below on your own and pause the video. Here's the result for A. Now try B. All right, there's the result for B. And it's helpful there to have a common denominator, right? Before we can add the 2 and the 5/3, we have to have both having a common denominator. So 6/3 plus 5/3 is 11/3. And it's probably best to just leave answers in improper fractions. Mixed numbers don't work so well in algebra. That's it for this video.